between a rectangle and a rhombus is that the rhombus, all four sides are the same. A rhombus is actually closer to a square than a rectangle, but in a rectangle, you got the 90 degrees. In a square, you got the 90 degrees plus all the sides are the same.
Right.
Okay. So the challenge here is how to remember all these. And you try to go down like the most specific. And it's a lot of busy work. So the problem you presented in your
Example.
notebook there is a coordinate problem. We're going to get to some like that. But there's some other things like in a rhombus, a lot like a kite, the diagonals meet at 90 degrees. They also bisect each other here.
By bisecting, does that mean like hitting at the
Cut,
same point or coming
cut
to
in
the
half.
same?
Cut in
Oh,
half.
okay.
So like this left is the same as this right. This top is the same as this bottom. Um, in a rectangle, the diagonals are congruent. Same with the square,
Right.
things like that. In a parallelogram, the diagonals bisect each other. So this is congruent to this. Actually, I use two lines, then 1, 2, 3, 1, 2, 3, but they don't necessarily meet at 90-degree angles. So there's all these like little properties that make them specific, makes them unique. And it's pretty overwhelming, but the first differentiator is the number of parallel sides. And then you kind of got these subcategories to think about as well.
I see.
Okay. So for any coordinate geometry problem, and I'm gonna draw a general shape here. A, B, C, D. Okay. Now this is just drawn arbitrarily. It's not meant to be. It could be that things are parallel or congruent, but that's not the whole point here. You have four segments. You have A, B, B, C, and then the order matters. You want to go left to right. A, D, B, C. You really want to go left to right.
Right.
And there's two things you want to know about each of these. So I'm going to suggest, and that's how we're going to do some problems today, is we're going to write the segment, and then we want to find the slope of that segment, and then the distance. And you almost want to get in the habit of doing this for all of them, all of these problems, regardless of whether
You have
even
to
if
or
you
not.
think, yeah, it really will save you a lot of effort. So this information tells you what it is, okay? And the reason you start with slope is slope tells you if two of them are the same, that means it's one parallel sides. If A and D, if these two are the same, and then the second, fourth are the same, then it's some sort of a parallelogram. Because it could be nothing. It could be, you know, no sides parallel, but then it could be a kite. That's where you got to also do the distance between, and you're looking for those sort of things. All right. So, again, I've sort of drawn this arbitrarily. It doesn't really matter where the axis is. Let's just say the axis is there. When you do slope, you should always do it as rise over run. What is the slope from A
4/5.
4/5? B to C. So B to C is going. This is not drawn great, but consider it that. What's the rise over the run
Would
from
that
B
be
to C?
down?
It's down, so it's negative.
So -5/6.
Looks like it's got one more, -5/7.
Oh, my bad.
Okay, and then I always recommend making a little sketch here because you got to be careful that you don't like go D to A and go the wrong direction. From A to D, it's down to and right.
5.
Uh, yeah, 5. That's again, it's drawn pretty poorly, but and then D to C, again, like make sure so this one's up 1 and right 7, so it's 1/7. So at this point, you know that there's nothing that's parallel. So it's either a quadrilateral or it's a kite. Now it
Right.
doesn't really look like a kite, but I mean, you don't want to make an assumption. The
Mhm.
next thing is to find the distance. And that's why you actually, there's two ways they do it. There's the distance formula, but all of these are are Pythagorean theorem problems. Did you guys talk about that at all in class?
A squared plus B squared plus C squared.
Yeah, equals c squared. Did you guys talk about that at all? Because that's really the better way to do it. They probably emphasize the distance formula, but
This, wait, what was the distance formula? Because I may have taken notes. I may have written something down about that.
yeah, distance formula is y2 minus y1 squared plus x2 minus x1 squared square rooted.
I'm pretty sure that's what she has us doing. But
Yeah,
the
right.
the A squared plus B squared plus C squared, I might be wrong, but that seems like less work,
It is.
or it might be a little
It,
quicker.
it and it's equal here. You said plus c squared a couple times. It's equal. So the way that that works is, and you kind of already have the numbers here, is you know that like a is 4 and b is 5.
Mhm.
So for this first one, we'll just do this first one. It would be 4 squared plus 5 squared equals c squared. 16 plus 25 equals
25.
c squared. C is the square root of 41.
So you just put 16 plus 25 on the other side, and then that's what
Yeah.
C equals. Okay, I get it.
Yeah, the square root of that. And then for b to c, for example, you said down 5, so that's 5, and then right 7. So it's, yeah, this is 5, this is 7. So
25 plus
it's
49.
yeah, 5 squared plus 7 squared, square root of 74. Yeah, 74.
Yeah,
And you can see you're actually getting it from the slopes here. So from A to D, yeah, it's down 2. That's 2 and 5. So it's the square root of 2 squared plus 5 squared, which is square root of 29. And then D to C is 1 and 7. So it's square root of 1 squared plus 7 squared equals the square root of 50.
right.
And none of these are the same. Since none of these are the same, kites require uh, segments to be the same. So it's just a quadrilateral. So the questions, and you're kind of doing this in your proof thing, which isn't really a proof, but it's like the question is, what is the most specific name for quadrilateral ABCD? And in our case, the most specific name is quadrilateral ABCD. There is nothing more that we can say about it because
Because there's
there's no parallel sides, which means it's either kite or right kite. And it's
mhm,
not a kite because none of these are the same.
right. I see. I mean, and then you say the A B C D as well.
I'm sorry, say that again.
Well, wait, scroll down a little. Oh, so you say quadrilateral, and then A B C D just as the points, or
Yeah, yeah.
okay, all right, I get it.
And they'll pick cute words like MATH or
Mhm,
whatever. I don't know, whatever words they're thinking of. They
right.
don't choose bad four-letter words, so
Mhm.
you don't worry about that. Okay, let me look up some problems now for us to try. Do you have any graph paper by chance?
No, but I can make. I mean,
Yeah.
I can try
So
to.
do you want to do like you want to do a rough sketch, like even like you don't have to use graph paper, but you need to sort of know, is B above A, is it,
Yeah. No, I
relative to
can.
like, yeah.
All right.
So I'm just looking for some problems and then we'll let's see if I can find any. All right, so here we go. All right, so problem number 1 here. I want you to make just a rough sketch of this, and then I'll snip in the answer, and then we'll go from there to
All right, I'm just making my graph 1 sec. Okay. Negative. All right, I've got it sketched out.
so
Do
let
I
me
start? Do I start doing that table?
yeah, it might help if you what you what you want to do after you get the graph of it, and hopefully yours looks something like this,
Yep, exactly
is
like
you
that.
really want to label them from left to right. So A to D, B to C. This time it is C to B because it's still left to right, but then it's A to B. The
Okay.
order does matter. And the next thing you might do, and it's easier for me because I got a grid. That's what I was asking if you had, um, is to draw the four triangles. That gives you the slope and it
There.
gives you the sides.
Yeah.
Okay. That would be my recommendation here. So I'd like you to calculate the slope, and I would not simplify the slopes because the slopes give you the numbers that you're using in the distances.
Right. Okay.
So take a look at that, see if you can come up with those numbers, and then we'll talk about what it is.
All right, I got 6/3, -2/5, -6/3, -2/11.
Right. Those look reasonable. Um, double check. Looks good. Look good. Good. Two. Good. Okay. So your distances, you're just squaring the two numbers. So it's like 6 squared plus 3 squared, which is whatever it is. And 2 squared, always the positive. You don't need to worry about signs.
Mhm.
Okay. And then 2 squared plus 11 squared. So give me those four without the calculator, just the square root of whatever the number is. You're not going to reduce it.
Okay. 11 squared is 121, right?
Hmm.
All right, the first one, C equals 45.
Square root of 45. Right, did you
Then
add that
C
in?
equals
Yep.
29. Yeah.
Square root of 29. Gotta add that in.
CB equals square root to 45.
Good.
And AB square root is 125.
Yeah. So it's square root of and then the number. Good.
Okay.
Okay. Now we know that there's, wait a second here. Yeah. So are these, are there any parallel sides? Are any of these slopes the
6
same?
and 3B parallel, but one's a negative. So
Is that, yes, that's off. Okay.
yeah, so no, yeah.
Yeah. And it kind of looks like it's a trapezoid, like kind of like, maybe. Um, so then you go look at these and you see that AD is congruent to CB.
Hmm.
And I would recommend like labeling that, but that's not enough. That's not enough for anything. It's not enough for a kite because the other ones aren't congruent either. Like for a kite, AD would it be congruent to DC
Hmm.
and so on. All right. Any thoughts on that?
No, I mean, it makes sense,
All right.
but
So we'll do one
well,
more, maybe
yeah,
maybe more, but we'll do another one here. This one actually will be something, but
okay.
all right. So go ahead and make a quick sketch of that.
All right, got it. I got it.
Okay. Let me grab a snip of mine. And then what does your intuition tell you that the shape is? What are you sort of leaning towards? Yeah, yes.
Well, I think this could be a parallelogram. Things look sort of equal or parallel on both sides. But
Okay. So you're leaning towards parallelogram, that's fine. Give me the four segments from left to right, please.
all right, we go A to D,
Good,
D to C,
good.
D to C,
B to C, yep.
B to C, and then B to A.
That's right to left. You gotta go left to right.
Oh, A to B.
Yeah. Okay. So, I got kind of the advantage of this where I can make these triangles. Go ahead and I would figure out the slopes without simplifying.
All right. A to D is 10/3. Wait, no.
Okay.
Wait, yeah, okay.
It's not 10/3. Okay, I'm gonna just double
Eleven
check
over
that.
three.
Yeah, 11/3. There you go. Okay.
D to C is 7/9.
All right. Yes, I agree. Good.
B to C is 11/3.
Okay.
And A to B is 7/9.
Okay. Now, just looking at the slopes, what do you know about A to D, A to D on the left here, and B to C? What do you know about those two based on the slopes?
Well, that they're both A to
You know,
D and B to C is equal, and D to C and A and B are equal.
right. They have the same slope. On
Mhm.
lines that are parallel have the same slope.
Right.
So you now know that this is a parallelogram,
Yeah.
but maybe and if we go back up don't make the mistake of thinking everything is a parallelogram. Everything's a quadrilateral. It could be a rectangle, a rhombus, or a square. We don't know yet. So we're going to find out. So we got to find the distance between all of them. So you're going to use these slopes here. Do not simplify the slopes to find the distance. You do need to simplify the slopes for M, maybe, but for the distance, you won't use those values.
Mhm.
In this case, it doesn't actually.
All right. Um, A to D is the square root of 130. D to C has a square root of 128.
Uh, isn't it 81 plus 49?
Yeah.
Uh,
81. Oh, shoot. 81 plus 40.
49.
130.
Yep.
Yeah, I was
Keep
off
going.
at 130. B to C has a square root of 130.
Yep. It's the same as AD, same
Yep.
numbers. And then
And
this one's
yep.
also.
Mhm.
So this is different now. All of the sides are congruent. So it's like, well, which one is that? So which of these has all four sides congruent? Well, it's a square or a rhombus. A rectangle only has opposite sides congruent. So what is the difference between a square and a rhombus? I always tell students the rhombus is the square pushed over. Kind of imagine sticking you got a little thing
Yeah.
there and you push it
You put,
over a little
yeah, so
bit.
this would be a,
So it's pretty obvious by looking at it. It's a rhombus, but to be sure, you have to figure out, well, do these meet at 90 degrees? Do any of the angles meet at 90 degrees? So this is a small little side note. Perpendicular lines have opposite reciprocal slope.
parallel lines have opposite reciprocal slopes.
Yeah. And then another way to do it is that their product, when you multiply them, their product is -1. So is the product of like AD and BC -1? The answer is no, because there's not even a negative, but we're talking about the slopes now. The product of their slopes. I should actually add that in there. Slope is -1.
I see. Makes
Okay, you ready to do another?
Yeah, sure.
So you didn't have to like do all this, but I really recommend doing this. Like there are problems where like once you find like the slope, you don't need to do all the distances, but I would just do them all. They're not that hard. They don't take that long. But what the teachers won't do is they don't necessarily give you enough space to graph them all, but they should, but they don't. And yeah. All right, so this one I'm going to handwrite because the words tell you what it is. All right. So I want you to graph that and then tell me what you think it is.
All right. I think this is a square.
Okay, so what do you need to prove for something to be a square? Let's go back and look here. A square is a parallelogram. So what's the first thing you have to do to prove that it's
We need both
that
sides equal.
both opposite sides are congruent? But you
Opposite
need a little
sides.
bit more than that. What else do you need?
For a square or for
Well, every square is a parallelogram, so it has to start with what does it require? What's required for it to be a parallelogram?
they have to wait, what's the word for it being right in the middle? That X can it's not
Don't worry about the diagonals. That's less important. What do we know about the sides? Besides them being
two
congruent.
sides. Yeah, two sides congruent.
And what is this line here?
Oh,
Double line
they're
here.
parallel.
Yeah. So
Yeah,
that's really like the first thing to proving that this is a square is to first, and it comes from that table, opposite sides congruent, opposite sides parallel. Then you want to show that consecutive sides meet at 90-degree angles. And then from opposite sides congruent, you're also going to find that all sides are congruent. So it's not good enough to just say, oh, it looks like a square. It's not good enough to make the table that we did. You have to make the table and say all this stuff. So that's where that sort of that reference sheet comes in handy. Um, let me grab what I'm trying to say here. Um, yeah, like you have to show enough to prove that it is, and it's this here. So it comes from the table. So you want to make this table with all the sides, and then you have to actually say all this stuff. Is that kind of clear?
yeah.
All right. So could you give me the 4 segments from left to right?
E to F, G to F,
Okay. So what happens if they go up and down? Is there a left or right?
You use the bottom one, right?
Doesn't really matter, but you have to be careful with your slope. Your slope is undefined on vertical lines.
Oh, I see. Okay. H to
So
G.
H to G, and what's the last one?
H to E. Yeah. All right.
Okay, so come up with your slope and your distance for each of them. The problem with the undefined one, I mean, you can just count, in this for the distance, but slope, if it's division by zero, it's undefined.
And wait, what do you do? So for there's well, I know you just said it's undefined, but like if there's no rise, would I just write the run so it'd be zero
Yeah.
over? Okay.
So horizontal lines. So there, again, it's kind of
So
like,
wait, question. So just for an example, E to F would be 0/5.
yeah, horizontal lines. And you could
Okay.
write that. You could say 0/5, which equals zero. Horizontal lines have zero slope,
Mm-hmm.
which is not the same as no slope. Vertical lines have no slope or preferably undefined slope. And the reason you might keep these numbers is because then you can stay with the whole 0 squared plus 5 squared, which ends up being just 5. But that's up to you. Because like G to F, as you're about to find out, is 5 over
Over
0,
0.
which is undefined. But then the distance is 5 squared plus 0 squared, which is 5. A square root of 25 is 5. So that's why we're simplifying.
H to Z 0/5, and then HE is 5/0.
So right now, all you know, like all you know is that the opposite sides are congruent. All sides, you know that all sides are congruent and that opposite sides are parallel. So all you know right now is that it's either if we go back to our picture, it's either a rhombus or a square because they both have all sides congruent. The difference between a rhombus and a square is that a square meets at 90-degree angles and a rhombus does not. Now I know visually you can see that when you graph this that it looks like a square, but you'd want to say that ops the consecutive sides meet at 90-degree angles. You actually have to say that for this.
But okay, oh, I get it. I get it. All right, let me do well, I guess oh, I see. Are all of them 5 then?
Here is probably our last one, depending on how long it takes. Um, Same thing here. Make a little graph of this if you can.
think I got it. Oh yeah. Wait, is that what?
Yeah, I mean, maybe not exactly what you got scale, but so what do you think? What do you just looking at it, what do you think it is? What's the most specific name of it?
I mean, it could. I think it is a parallelogram, but I think it's a.
Okay,
I think it's a
let's say
rhombus.
could be a rhombus, could be,
Yeah,
we'll see.
could be.
So
Let's see.
give me the segments left to right, left to right.
Wait, my bad. I'm connecting something. Okay. Q to D.
That is not left to right. So D is more left than Q.
Oh, you're okay. Let's just start D to A. Wait,
D
can
to
I
A.
start up there or no?
Sure, yeah, start wherever
All
you
right,
want.
yeah. D
Yeah,
to
just go
A.
left to right. Yep. What's the next one?
A to U.
A to U, good.
Q to U.
Okay.
D to Q.
All right.
Got it.
All right, so go ahead and find the slope for each of these, please.
I think I got it. D to. Oh wait. Should I tell you these, or should we just
Yeah.
do?
Yeah, go
Okay.
ahead and tell me the slope first.
0/8.
Okay, which is really 0, go ahead.
Yeah. -12/2.
Um, so, okay, one of the problems here is that this isn't scaled um, by 1. It's scaled by half. So it's actually, that's gonna affect some of your answers. I should have mentioned this earlier.
Okay.
So it's actually 0/4.
So would it be -6/1?
Yeah, for AU. Yes. All of them are gonna get a cut in half. Okay, what about
X1
QU?
0/4,
Yep,
and the other one is -6/1.
good. So we know that it is for sure a parallelogram because opposite sides are parallel. And we're gonna find that the distance is 4 and 4, that the top and bottom are congruent, and that uh, the left and right are congruent. This is the 6 squared plus 1 squared, square root of 37, 6 squared plus 1 squared. Notice I'm just taking the positive of it. I'm not worrying about the sign. It does become positive. So all you know right now is that it's a parallelogram. Opposite sides are congruent, opposite sides are parallel. To decide if this is a rectangle, we need to know if this meets at 90 degrees. Now, it sure does not look like it, but the correct way to do that is to take the product of the slope, to take like dA slope times AU slope, which is 0 times -6. Does this equal -1? The answer is no. So those definitely don't meet. It's all the sides are not congruent, so that is not a rhombus, and it's not a square if they don't meet at 90 degrees. So the key really is like after you prove something is a parallelogram, you look at the slopes to figure out whether it's a rectangle or a rhombus or all 4 sides, and then the angle to figure out if it's a rhombus or a square. All right, if you can print those reference sheets out,
Yeah, I'm
but
gonna.
I'll